of the internet, welcome to my new YouTube channel. I actually run another YouTube channel called Crud Bucket. It's quite successful, but I've decided to branch off and make this new one regarding my amateur CNC adventure. I recently picked up a machine from eBay. It's called a CNC 6040, so it's 600 by 400mm table size, and I've had a pretty interesting experience with it so far. I'm going to go ahead and show you the machine now and show you what I've made so far and what modifications I've made to the machine, and just any other tips and tricks that I've found to be quite useful so far. So I hope you enjoy. Please comment and subscribe if you're at all interested. Cool. Cheers. Okay, welcome to my garage. It's nothing special, but it does the job. Alright, so this is the machine, the 6040, which you can get off eBay around about 1,700 Australian dollars. It comes with the step motors for all three axes, a spindle with a variable frequency controller. You've got your drivers here for your stepper motors, so it's got a breakout board and three separate stepper motor drivers inside with a power supply. That's actually been quite good so far, I find. What else? The table is quite rigid. There is a little bit of flex in it, which isn't that great, particularly on the Z axis here. If I just sort of deflect it forwards and backwards like that, that just really limits the depth of cut you can take and the feed rate at which you can drive it into the material. I particularly notice on aluminium, you got to really take it slow, otherwise you're going to get a terrible surface finish just from tool chatter. I had two major issues with this machine. One was the bed was not square to the Z axis. So what I've done here is I've bought a 10mm aluminium plate, and then I've bolted it down, put several holes in it and tapped them so I can clamp workpieces to it later on. And then I've just gone and faced the entire bed, and now I know for sure that it's square with my cutter. And so far so good. So that's one thing you might want to do, you might want to consider if you get this machine. That aluminium plate costs $60, which isn't too bad really. Another major issue that I've had, and a lot of people out there on the forums have had, is that the motors for your the wires for your stepper motors, sorry, they come inside a cable chain and they're all ducted nicely to the stepper motors. The issue is the wire is absolute crap. So it took me a while to find out what the issue was, but I just had an intermittent break in one of the stepper motor wires on the Z axis, and that, I actually had it on the Y axis as well, and all of a sudden you'd be cutting and it would just go off on a tangent and just destroy your workpiece. So that's quite frustrating, and it can end up breaking tools and things like that, which isn't ideal. So what I've done is I've just ordered some shielded 4-core stepper motor wire from online. I think it was about $3 US per meter. I ordered 6 meters and just replaced all the cables, and it's been brilliant so far. Got rid of the cheap little Chinese connectors that you get with it as well. I've used what's called EC2 bullet connectors for quick disassembly if I ever need to take it apart. But other than that, yeah, it's going well so far, and I'm having a lot of fun with it. Alright, next up I guess I'll drive around and show you my Mach 3 parameters. Here's one interesting thing that I've neglected to mention so far. I kind of forgot about it because it's under the table, but this unit comes with a water pump, which is really great for cooling the spindle, especially when milling the more resistant alloys, and just long use of the spindle would get very warm. So it's got a bucket under here. We'll just affix the pump to the side of the desk. Very temporary installation because we're actually moving house soon, but it works brilliantly. I have to say, it really keeps that spindle nice and cool, and it's going to improve the longevity of it as well. That's another great thing about this machine. Okay, the software that I've chosen to drive the machine is Mach 3. It's very popular and quite cheap. A lot of functions and none of which I've really explored, but it is great. It runs the machine very smoothly, as you can hear from the stepper motor. So I'll just drive around the table and you can sort of see how it goes. So you can see it's all relatively smooth on each axis. I'll just read out my parameters to you as well, in case you want to match the settings. The one thing I did was up the jogging speed. I think I doubled it because it was a little bit slow, and so far I haven't had any issues whatsoever. Right, okay, here in motor tuning, my x-axis is, the steps per revolution is 320. That's the same for every axis because all of the ball screws and lead screws have the same pitch. My velocity in millimeters per minute is 3,000. I believe the recommended is 1,500. Acceleration is 300 millimeters per second. Step pulse is 10 microseconds, and dir pulse, whatever that means, is set to 5. My y-axis is set exactly the same as my x, and the z is set to 500 millimeters per minute for the velocity. Acceleration is 150 millimeters per second, and same values for the step and dir pulse. Now, the sacrifice that I've made by upping the velocity of my x and y, it travels a lot faster, but when you run a stepper motor faster, you lose the torque. That's because it has less time on each pulse to snap to the magnets, if that's an explanation at all, but it's not so bad with jogging. When your tool is under load and more torque is required to move each axis, that's when you're going to see issues. So the slower you drive it, the more torque you're going to have, the more power your stepper motor is going to be able to deliver, and that is going to be beneficial to avoid skipping steps and keeping everything as accurate as possible. Right, now I'm just going to speak to you a little bit about software. I personally am designing all of my parts that I want to make in SolidWorks 2010, and for me that's just easier because that's the CAD software that I've been learning for the past couple of years and I'm comfortable with. There's a lot of CAD software out there that you can choose to use. As long as you can export your file as a DXF, then you're really free to do whatever you want. Now, from the CAD software I go into the CAM software, and I'm using VCarve Pro as recommended by a good friend of mine who also put me onto the CNC machine. That works really well. It looks just like that. I'm not sure if you can see on the camera, but been working really great for me so far and very user friendly. From there I'm obviously going to Mach 3 to run the G code, which I export from the CAM software. Okay, I think that's probably enough about the machine so far. If you guys have any questions, or if you're looking to buy one, please just send me a message or leave a comment and I'll try and get back to you with any information that I have to help you out. Right now I'm going to show you just a few little bits and pieces that I've made so far and give you an idea of what you can make with this machine. Here's one of the first things I sort of made. It's just a variety of clamps for the table, you know, with various other bolts and things like this to hold workpieces down, which I find is very critical with CNC. Right, well here's some of the things I've made. This is a quadcopter and I've made these legs for it. It's made out of polycarbonate and bolted on, so you can put a GoPro underneath the quad. I've also made like a little extension plate out of acrylic, so you can stick the GoPro out the front and not have the propellers in view. Yeah. I've got some other small things here, like this is actually just a little boom clamp for a little project where I mounted my GoPro on just an old helicopter boom. Something I haven't really used, but it was just sort of fun to make, and learned a few things about it. This can actually swivel on there, and it's just bolted to the boom clamp itself. Here's a little swash plate leveling tool for a mini Proteus as well, which is kind of cool because it's a funky shaft size. And this is probably the piece that I'm most proud of. It's a little heatsink motor mount for my Goblin. And that, the idea is just to conduct a little bit more heat away from the motor and vent it off through these cooling fins here. I think it works quite well. So, one other final thing I've got to show you is just my charging station, which I think you'll quite like. Here it is. This is basically what I've cut on the CNC is the white acrylic plate, which you can see here. Underneath is mounted a power supply which converts 240 volts to 28 volts DC. The chargers are recessed inside of it, and it sort of interlocks together with this plate here. It's all screwed in and mounted nicely, and it works really well. I think it looks pretty cool too. So that's about it for what I've made so far. Obviously I've made a lot of things and I stuffed them up, but that's all part of the learning process, and that's the great thing about CNC and workshop fun for me anyway. That's about all I've got for the moment. Obviously I didn't go into too much detail, but I'll try and help anyone with questions they might have. I'd just like to thank a good friend of mine, Aaron. His name is DCT Teacher on YouTube. He's actually got a smaller version of this CNC machine, and he's really helped me out a lot in getting to where I am, being able to make things and having a good amateur CNC experience overall. So cheers mate, and everyone else stay tuned. I'll try and get a few videos up in the next couple of months, and I hope you like. Alright, take it easy, Luke out.